Acceleration is a change in velocity. This is a person who's falling. He's accelerating. We can tell that because the positions are getting successively farther apart. And so that tells me the velocities, or the speed's increasing. Speed's changing. That means there's a change in velocity. And that means that there's an acceleration. Okay, fundamentally, that's what that's telling me. Acceleration is a change in velocity. Now, I want to make a point about this. Suppose we put on green velocity arrows to show you're going from point 1 to point 2. You put on a green arrow from point 1 to point 2. That's your velocity arrow. That's how you had to move to go from here to here. Then I have an arrow here, an arrow here, and an arrow here. The arrows are getting longer. Acceleration is the change in velocity. As a vector problem, we do it like this. Let's take my final vector and pull it down here. Take my vector right before it and bring it down here. And the question is, I want to go from this vector to that vector. What do I have to add to this one in order to get to this one? And the answer is, I have to add this little bit right here. Okay? So the acceleration is negative. It's an arrow that points down. And that's important. That's important. So I want to take a look at some motion diagrams. And this is motion diagrams of a car moving on a level road. I'm going to ask this question. Which motion diagram or diagrams corresponds to a positive acceleration? Now, we define things that point to the right as positive, right? Now, think about this. Okay, so think about the direction, not of the velocity. Think about the direction of the change. Is the direction of the change to the right, in which case it's positive, or is the direction of the change to the left, in which case it's negative? Talk to your neighbors. Which graphs are positive accelerations? Which ones are negative? Let's do positive first. And go ahead and talk, and I'll call for a vote. Let's take a vote. Which ones are positive? A and C. A and C. This one, it's positive. It's getting more positive, right? Well, that's a positive acceleration. And think about it. To go from here to here, if I'm going to add something to this vector to make it equal to that one, I have to add something that goes to the right, right? So the change points to the right. Now think about C. This is an object which is moving to the left, but look, it's slowing down. So it's going to the left, but the amount that it's going to the left is decreasing. If I'm going to go from here to here, what do I have to add in order to get there? Think about it. I got a vector that's big and pointing to the left. And I need to then end up with a vector which is pointing to the left, but it's smaller. What I have to add to it is a little tiny vector that points to the right. So if you're going in the hole, but you're not going in the hole as fast anymore, that's a positive change. That's a positive change. Now, how about this one? Positive or negative? Negative, because it's moving to the right, and then it's not moving to the right as quickly. You're going from here to here. The change points to the left. Okay? How about this one? You're going to the left, and you're going to the left faster? Negative. That's a negative acceleration. Now, there's another way that you can think about this. I want you to think about forces and think about the direction you'd have to push to make these changes in motion happen. Something we'll talk about in a couple of weeks is what causes motion. And what causes motion is forces. So suppose you have like a cart, and you want to make it do this. You want to push it to the right, and it's with an increasing speed. Which direction do you have to push? To the right, right? Suppose you had something which was moving to the right already, and you want to make it slow down. Which way do you have to push? To the left. Oh, yeah, so I'm pushing to the left. That's a negative force. That's a negative acceleration. How about this? It's moving to the left, and I want to make it slow down. I have to push to the right, okay? So you can think about that. You can think about that, and that will help you. Now, the direction is going to be crucial for us, but the other thing that's going to be crucial for us is the magnitude. And the magnitude is the size of the acceleration, okay? How big is it as a number? And we did some calculations of accelerations last time. But I want you to think about this. 4 motion diagrams show the motion of a car on a straight road. Rank these motion diagrams by the magnitude of the acceleration. There may be ties. Talk to your neighbors about this and think about the magnitude. How big is the acceleration? Talk to your neighbors, and I'll call for a vote in about 30 seconds. All right, let's take a vote. Magnitude of acceleration. And if you have to do multiple hand gestures, you can just cycle through them. We're going to rank them. And let's go for the biggest. Which one has the biggest acceleration? They're all the same. Ha, 4-way tie. They're all different directions, but the magnitude is all the same. Look at successive values and think, how big is the change? How big is the change from here to here? A little bit. How big is the change from here to here? A little bit. The same little bit. Same little bit. Same little bit. And so in each case, the size of the change is the same, the direction of the change is different, but the magnitude is the same. One thing we'll talk about when we talk about forces, in order to make these 4 changes happen, you'd have to push the same amount in order to make this go.